Okay, so 1 over x plus 2, no factoring is possible. So you set the denominator equal to 0 to find the excluded values. Here we just have a single excluded value. X cannot be -2. Now we want to see, okay, is this a vertical asymptote or is it a whole? No reducing is possible. There's no common factor of the numerator and denominator. So that means that it's a vertical asymptote. Okay, so drawing in the vertical asymptote is part of the graph. So you do need to draw it in to get credit. Okay, next I'll check for horizontal asymptote. Numerator has no x at all. That's considered degree 0. Denominator has invisible 1. So denominator has the bigger degree. So that means the horizontal asymptote will be y equals 0. Next, I'll check for intercepts. X-intercept, I set the numerator equal to 0. But the numerator cannot turn into 0. So there's no x-intercepts. Y-intercept, that's where you plug in 0 for all x's. Okay, so here we do have a y-intercept. When x is 0, y is 1/2. Okay, and then now for the table of values. So -2, the excluded value should be like your center number. All right, that number itself is undefined, but 0.1 in each direction, a whole unit in each direction, and -10 and +10. Okay, so over here, though, you don't really need to do all the numbers. You certainly can if you want, but you already have the intercept and you already have the asymptotes. So you can already tell the graph would have to start at the top and go through here. And please remember to put your arrows on both ends of the curve. Okay, we know there's no curve down here because it has to pass the vertical line test. So last question, is the curve here or here on the other side? So I'll just pick one number to the left of the vertical asymptote. I'll just do -3. So when you substitute in -3 for x, you get 1 over -1 or -1. Okay, so -3 comma -1 is a point on the graph. So that means that the curve is not up here, it's down here. Okay. Yeah, moving on to b of x. Again, no factoring is possible. So you set the whole denominator equal to 0. Sorry. Okay, so is this a vertical asymptote or a whole? No reducing is possible. You cannot reduce the x's because this x is not a factor. It doesn't multiply the rest of the row. Okay, so it'll be a vertical asymptote at x equals +3. For horizontal asymptote, we compare the degrees. They're both degree 1. So when that happens, you divide the leading coefficients. So 1 divided by 1 is 1. So y equals +1 is our horizontal asymptote. Intercepts, x-intercept, set the numerator equal to 0. Okay, so when you set x equal to 0, you get x equals 0. Okay, and double check, make sure it's not an excluded value. It's not. Okay, so 0, 0 is your x-intercept. So it'll also be the y-intercept, but the work would be 0 over 0 minus 3. 0 over -3 is again 0. Okay, so again, you don't really need to do the full table. You already know the curve is down here because it has to touch this x-intercept. So it would look like this. Okay, and I'll just try 1 point over here. So I'll try 4. When x is 4, y is also 4. So we have a point here, and that tells us, okay, the graph is like this. Okay, and last one. Here there is factoring to be done. The numerator cannot, but the denominator, both terms have an x, so you can factor the x out. So factor by GCF. So now when you set the denominator equal to 0, the x itself could be 0, or the x plus 2 could be 0. Okay, so there's two excluded values. X can't be 0, and x can't be -2. Okay, now each of these either forms a whole or a vertical asymptote. So this time we are able to reduce. X squared is x times x. This x is touching the parentheses, so it is multiplying the rest of the row. Okay, so we are able to reduce one x from each section, which simplifies to x over x plus 2. Okay, so the EV of -2 is still there. So that'll form a vertical asymptote. But 0 is no longer an EV. Its factor got canceled out. So that means 0 will form a hole instead. Okay, so vertical asymptote at -2. And then for the hole, the x coordinate is that excluded value. And to get the y coordinate, you substitute it into the simplified form. So the y coordinate is also 0. Okay, so you have a hole at the origin. Okay, horizontal asymptote. Degrees are tied at 2. Remember, you don't combine these because they don't multiply each other. So when the degrees are tied, you divide the leading coefficients. So 1 divided by 1 is 1. So your horizontal asymptote is y equals 1. Okay, so now intercepts. So x-intercept, set the numerator equal to 0. Okay, so you can set either the original or the simplified one equal to 0. It doesn't really matter. Okay, so you think, oh, okay, 0 is an x-intercept, but 0 is an excluded value. So it can't be an x-intercept if you're not allowed to use it at all. Okay, so that's something you need to check for when you do the x-intercept. You need to make sure that your answer is not an excluded value. Okay, so since the only answer is actually an EV, that means there is no x-intercept. And y-intercept, again, you're supposed to plug in 0 for all x's, but 0 is not allowed to be used at all. It's an excluded value. Okay, so there's no y-intercept either. Okay, so again, you could make your full table of values around the excluded values, but we already know that the graph has to touch this empty circle. Okay, so it's gonna have to, start near the asymptote, go right up to the edge, and then continue on the other side. Okay, so again, you don't really need to plug in points because the graph curves towards the asymptotes, and it has to go towards any intercepts, or in this case, holes. Okay, and then we do need to figure out what happens on this side. So to the left of -2 is -3. So I'll plug -3 into the simplified form. Okay, so when x is -3, y is +3. So knowing that we have a point here means that the curve is in the upper left quadrant. So okay, so yeah, for these three graphs combined, I only actually plugged in like 3 points. right? I wasn't filling out 6 points per table, right? Sometimes you can use the intercepts, use the asymptotes to get the shape of the graph a lot more efficiently. Okay, so yeah, any questions on the graphing? Yeah.
So the horizontal asymptote is based on the degree of each London function?
Yes. Yeah, and then there's three. Yeah, if they're tied, then you look at the leading coefficients. If the denominator has the bigger degree, it's y equals 0. If the numerator has the bigger degree, there's no. Yeah. Okay. So let's jump to the back of the handout now, because we didn't get to this last time. Okay, so we're gonna go over a real life application of the solving rational equations that we introduced last class. So we have something called like the shared work formula. So if two things are either collaborating or sort of doing opposite actions, we can calculate the amount of time it will take to do the task. Okay, so if you could please write down this formula. So time if together is the numerator divided by the time if, so capital A is whatever is the first object in the problem. Okay, so you take the time if the two things are working together divided by the time if A is by itself. Okay, and then you either add or subtract a second fraction. So the numerator is the same. It's again the time if the two entities in the problem are working together. This time the denominator is the time, wrong word, sorry. The denominator is the time if B is alone. Again, B is whatever the second thing is in the problem. Okay, and together that equals simply 1. Okay, so now it's not like the quadratic formula where you both add and subtract. Here you either add or subtract. So you add if they help each other. Okay, if they're working towards the same goal, if they're doing the same action. On the other hand, you subtract if they're opposites. Okay, so if one is trying to, do one thing, but the other is doing the opposite, then they would be hurting each other, right? They would be slowing each other's progress. So in that case, you would subtract instead of add. Okay, so let's look at an example together. Okay, so let's say that two friends, Haley and Lizzie, they need to grill a bunch of hot dogs for like a tailgate party. So Lizzie knows that it would take her 12 minutes to grill enough hot dogs if she were doing it by herself. Okay, now when they work together, combined, it only takes 8 minutes to get enough hot dogs. Okay, so now what if the next time Haley's by herself? How long will it take Haley to grill enough? Okay, so we're gonna use the formula from above. Okay, so looking through the problem, it doesn't really matter who is A and who is B. It says right here that Lizzie knows it would take her 12 minutes to grill them by herself. Okay, so we'll put that right here. Okay, so that's the time for person A, in this case, Lizzie, to do it by herself. Okay, and then we also know that when they work together, it only takes them 8 minutes. Okay, so both numerators will be 8. Okay, and then now, is it a plus or a minus? plus. They're helping each other. They're both grilling hot dogs, right? It's not like one person is grilling and the other person's like eating or throwing them away, right? They're both creating grilled hot dogs. Okay, so for this problem, we add. Okay, what we don't know is how long it would take person B, Haley, to grill them alone. Okay, so that's our variable. So, just use a X, any letter is fine. Okay, and equals one is not a letter, so it's always equals one, right? The one represents like the complete job, right? So basically this fraction is what fraction of the job person A does. This is a fraction person B does. Let's make sure, let's confirm. Okay, so yeah, there's multiple ways you could solve this problem, right, with the goal of getting the X by itself. But just to show you, well, let me leave this here just so that we don't forget where we started. But the way I'll choose to solve this one, the method we've normally been using is getting a common denominator. So I'll go ahead and do that here. So 12 and x, right, they are not the same. So I'll need to multiply this one by x over x and this one by 12 over 12. Right? So it becomes 8x over 12x plus 96 over 12x. And now I can combine those into a single rational function. Okay, and the other side still just equals one whole, right? Again, you could turn it into a fraction if you wanted. Okay, but then another strategy I suggest is if you have a denominator, you can get rid of it by multiplying both sides by that denominator. Okay, so here we're multiplying both sides of the equation by 12x. Okay, so notice it's not 12x over 12x. Earlier, it was something over itself because you're only multiplying one fraction, not both sides. So to keep it balanced, you need to multiply both top and bottom. But if you're multiplying both sides of the equation, then you don't need to do top and bottom because it's already balanced out. Okay, so on the left side, the 12x gets used up to cancel the denominator. So the 12x is no longer there. So you're just left with the 8x plus 96. And on the other side, you have 1 times 12x. So that's anything times 1 stays the same. Okay, so here, this is not a quadratic, so we don't necessarily need to move everything to the same side. We could just instead subtract 8x from both sides and then divide both sides by 4. Okay, and so for word problems, I'll be asking you to give your answer in a complete sentence to show that you understand what the numbers represent. Okay, so again, if you just write 24, that will not give you credit. What does the 24 represent? It represents the number of minutes it would take Haley to grill by herself. Okay, so something like it would take Haley 24 minutes alone, right? That would be perfectly good. Okay, you do need to put the units for word problems. If you just say it would take Haley 24, 24 minutes, 24 hours, 24 hot dogs. So yeah, you will need to put the units in your answer for these word problems. Okay, so we'll do one more together. Okay, so NFL referee, right, that's for football. They're trying to fill up a football, right? They need to be inflated with air. But Tom Brady poked a hole in it, so air is leaking out. Okay, so normally the machine inflates the football to the proper size in 30 seconds. But if the machine is not active and there's a leak in the football, then in 90 seconds, the football will deflate back to nothing. Okay, so if the machine is on, but air is still leaking out of the hole, how long will it take the football to fill up? Okay, so this is based on a real life situation, by the way. I don't know how many of you follow football. But anyways, the first action, well, sorry, first we should notice that this problem is subtraction, right? Because here the two actions are opposites. That referee is trying to fill up the football, but Tom Brady is trying to deflate the football. Okay, so it's going to be the first fraction minus the second fraction. Okay, so this time order matters. When you add two numbers, it doesn't matter what the order is, right? 2 plus 3, 3 plus 2, you get 5 either way. But when you subtract, order matters. Okay, so how do you know which one should be positive and which one should be negative? Right, so the second one is negative because that's where the subtraction sign is. Okay, so the positive one, the first one, that should be the positive action. So that's the one that's like, creating or whatever. Yeah, so in this case, the positive action is filling up the football. So it says the machine will take 30 seconds to inflate the football. So that's the time for the first thing by itself. Okay, now the negative action, the thing that's doing the opposite, right? The leak is not trying to fill up the football, it's trying to empty it. Okay, so the 90 seconds for the leak, that would be the time for B alone. Okay, and it always equals 1. So this time the unknown is what happens if together? What happens if both things are happening at the same time? Okay, so both numerators will be x. Okay, your two numerators should always match. Whether they're both numbers or both the variable, they should always be the same. Okay, so how should we approach this one? Well, again, I would suggest focusing on this side and getting a common denominator first. We do not need to multiply this by 90 over 90 and this by 30 over 30. It would be more efficient to notice that 30 goes into 90. Okay, so we can simply multiply this by 3 over 3. All right, so now we get 3x over 90, and this one can stay the same, minus x over 90 equals 1 whole. Okay, so combining that together, 3x minus x, those are like terms. We can combine them. Okay, so 2x equals 90. Sorry, 2x over 90 equals 1 whole. Multiply both sides by the denominator of 90. The 90 gets used up over here, just leaving the 2x behind. Over here, we do multiply. And then lastly, divide by 2. Okay, and then give your answer as a complete sentence. Okay, so again, just look at the last sentence. Is normally it'll tell you what you're looking for, right? So if both the leak and machine are present, how long will it take the football to fill up? Okay, so it'll take 45 seconds to fill if both the machine and leak are present. Yeah, so I'll just give you a little advice. If you ever get a negative time, obviously that doesn't make sense. That may mean that you switch the two fractions. Again, with subtraction, with subtraction, order matters. Okay, so I'm gonna give you some time to practice using this formula. Okay, so go ahead and try the bottom two problems on this page, please. Okay, so for this problem, the two actions are the restaurant is trying to fill up a case with donuts, but people are emptying the case. They're taking donuts out. Okay, so the first number we see 6, that represents the restaurant making donuts and people buying at the same time. So that is the time together. So the 6 is the numerator of both fractions. Now, the two entities in the problem, the restaurant and the customers, they're doing opposite things. The restaurant is filling up the donut case. The people are buying donuts. They're taking donuts out. So this will be a subtraction problem. Okay, when the case is full, the restaurant stops making donuts, and it takes 10 hours for people to buy them all. Okay, so the 10 hours represents people taking donuts out of the case. So that's the negative action. Okay, so that's got to go in the second fraction, right? This one is positive because there's no symbol. This one is negative because the minus sign applies to it. Okay, so then the unknown is how long will it take the restaurant to fill up the case when there's no customers? So that's the positive action. Okay, again, always equals 1 whole. Okay, so solving this, again, there's many different ways you could do this, but I'm just going to get a common denominator. So x and 10, this one needs 10, this one needs x. Okay, I'm just going to combine these. Okay, then from here, we can multiply both sides of the equation by 10x. Again, not 10x over 10x, because you're not doing it to one side only, you're doing it to both sides. Okay, so 60 minus 6x equals 10x. Add 6x to both sides. And then divide both sides by 16. Okay, so 60 over 16, you can leave it as a fraction if you want. That could reduce to 15 over 4. Okay, so, either 15 over 4 hours, or that's in decimal form 3.75 hours. Or some of you chose to convert that to 3 hours and 45 minutes, which is also correct. Yeah, any of those forms would be fine. Okay, so again, I'll just do okay. And for the last one, yeah, the machine drill, the tunnel boring machines. So they are constructing, this is real, by the way. Like, I don't know if you guys know, like, how we can visit, like, websites from, like, Europe and Asia. There's actually, like, undersea cables that connect the continents. It's kind of crazy. Mm-hmm. Yeah. So, yeah, there's, like, yeah, literally boats that, like, drop the cables to the seafloor. How the internet works. Yeah. Mm-hmm. Okay, so yeah, so the two machines are drilling from opposite ends, and they're going to meet not exactly in the middle, but somewhere between. So the two machines are helping each other, right? They're both building the same tunnel. Okay, so that means that the problem will be an addition problem. Okay, so the first number we see 4, that's the first machine alone. Okay, so it doesn't matter if we put it here or here, because with adding, order doesn't matter. The second machine would take 3 years by itself. The unknown is if both machines are working. So here, the numerator is the unknown. Okay, so again, I'll get a common denominator first. Okay, combine into a single one. Multiply both sides by the denominator. Okay, and then from here, so what I'll ask all of you to do is give exact answers unless you're specifically told to round. Right, so 12 over 7 is a perfectly good answer, right? Or you can make it a mixed number if you want, 1 5/7. But this does not turn into a decimal nicely. When you divide in your calculator, it goes on, forever. So please do not round it to like 1.7 or even with more decimals. I would prefer it to be an exact answer. Okay, so again, you could say it takes 12/7 years or 1 5/7 years. Okay, so if both machines are working together, it'll take 12/7 of a year or 1 5/7 years. Okay, so questions about the word problems? Okay, so once you have that all down, you can flip back to the front side. Okay, so there's a few more rational equations, right? So these ones those are a little bit more involved to solve because the denominators are different. But yeah, so yeah, I'll leave my screen here because I see some of you are still writing, but please now go to the front and try to solve the 4 equations there. Exit ticket for homework. And yeah, next class we'll have a quiz. Yeah, for all of Unit 2. Okay, and then the test is next Tuesday. I'm still deciding. I'm not sure yet. Yes. Okay, I'm glad to hear that. Well, I mean, yes. Yeah.
I was wondering, I know this is really in advance, but do you know if we have any like tests or quizzes the week before winter break?
I think we do. Yeah, the Unit 4 test is scheduled for the Tuesday of the last week of school. Are you not going on vacation or?
Yeah, I'm going to my oldest sister's graduation. I think we're leaving. I'm gonna find out.
Okay. Yeah, I mean, yeah, if you are gone, I mean, you maybe could take it early, because the class before is a review. It's not anything new. Or, I mean, in my experience, it has not gone well when students take it after break because it's been weeks and they forget everything. So, yeah, yeah. Let me know if it's confirmed you're missing that.
Yeah.
And then we'll figure it out.
Thank you.
Yeah. Yeah. Uh-huh. 1.3? Well, it would have to be 1.3 repeating, right? That's how you get from 3 to 4.
What was the state?
Sort of. What does it say? 1.7 over 4 or? Yeah, so yeah, I understand the goal 3 times 1.3 repeating equals 4, but yeah, where you got to be careful about is rounding. Because I always want exact answers. So yeah, if it doesn't multiply exactly, it wouldn't be quite right.